All right, in this video, we're going to talk about inequalities. So now we have not equations, but inequalities, and a reminder uh, about a sign like this. If we draw a symbol like this means less than. If you put an equal sign underneath there, that means less than or equal to. Turn the sign around, this is greater than. And if you put an equals under there, that means greater than or equal to. So it's not an equality, it's not an equal sign, it's a inequality symbol. So we'll start with linear inequalities. That just means our biggest power of x is going to be 1. And then we're also going to introduce something that you will use in calculus, which we call interval notation, which is a way to express your answer when you have more than just one answer, but a whole infinite number of answers. So we'll get to that. Basically, for a linear inequality, you solve it the same way you would an equation. You want to isolate x on one side. So here I would probably subtract 3x over here so I can get rid of it there and add 2, get my constants over to the other side. So it cancels there. 4x minus 3x is x, less than or equal to if I add, what did I add? I know what I did. I should be adding 2, and 4 plus 2 is 6. There we go. But now what is this describing? This says the numbers I want are any number less than or equal to 6. So 6 would definitely be included, but any number less than 6 would also work. One way to illustrate this is with a number line. So if you think of 6 on the number line, including 6, you would say, okay, usually would denote that with a solid circle. And if it says less than 6, any number less than 6 would work, less than or equal to. So 5, 4, all the way down forever in the negative direction on the number line. So in some beginning algebra classes, it's fine to leave your answer as x is less than or equal to 6. But when we move to calculus, what we do when we want to express an infinite number of answers, a whole bunch of answers on a number line, we use what we call interval notation. And so parentheses, when we use parentheses, that means we're not going to include endpoints. Brackets mean we're going to include the endpoints. So here's what we mean by that. And we always go from the smallest number that is part of our answer and work our way to the biggest number. So what number is the smallest number that would be included when I say x is less than or equal to 6? Well, this goes all the way to negative infinity. So I'm just going to write negative infinity, comma, and I want all of the numbers from negative infinity all the way until I get to 6. So then I just put comma 6. Now in this case, we want to include the 6. So we're going to put a closed bracket this way on the 6. That means we want to include it. Now, if I put a closed bracket on negative infinity, that would be suggesting that negative infinity is a set number that you stop at. But as we know, you can travel forever in the negative direction. So you can never ever get to infinity, which means infinity will always have a parentheses around it when you're using interval notation, because we can't really include that. And so in interval notation, this would be read as all the numbers from negative infinity, not including, of course, to 6 including. And that's how we'll leave our answers when we get to calculus. Okay, let's try another one here. So again, solve it much like you would an equation. You want to isolate x. You probably want to do some distributing here. So 4x is less than or equal to 12x minus 8 minus 2x. So I have 4x is less than or equal to, I can combine 10x minus 8. Now, I want to show you there's kind of two ways to go about solving this from here. And one way I would highly recommend, but a lot of times we get used to, like, we always have to have x on the left side. And if I force myself to do that, so I'm going to show you two ways here. We'll go this way and this way. If I subtract 10x over here, 10x to both sides, that's going to leave me with negative 6x less than or equal to negative 8. And then in order to solve for x, I would need to be dividing by negative 6. And The way it works with inequalities, when you divide or multiply by a negative number, you have to reverse the sign. So this becomes, instead of less than or equal to, it becomes greater than or equal to -8 over -6. If you reduce that is +4/3. If you're wondering why that's true, maybe up here we can take a true inequality. Like let's say you take 5 is less than 10. That is definitely true. If I multiply both sides by a negative, however, -5 is actually greater than -10, right? So if you multiply an inequality by a negative number, you've got to reverse the sign. Let's write that down. When multiplying or dividing by a negative number, reverse the sign. Very, very important. Okay. Now, that's an easy mistake to make, as you probably could imagine. And so as you get better with your algebra, perhaps another way to solve this, and we'll get the same answer here, is if I, instead of moving the 10x over this side, I let the x's go to the right side by subtracting 4x over here. So that would leave me with 0 less than or equal to 4x minus 8. I just subtracted the 4x. I can add the 8 over to this side. This would be 6x. My goodness. Okay. I subtracted 4x from 10x to get 6x. I'm going to add the 8 over the other side. And then I'm going to divide. Notice I'm dividing by +6, so the sign is preserved. It stays the same. Now, I would just have to then learn to read this, that if this says 4/3 less than or equal to x, and I read that from right to left, that says x is greater than or equal to 4/3, which is exactly the answer we got here, and I don't have to worry about remembering to switch the sign. So if you either way is fine, but if you think about when you're doing inequalities, try to get the x on the side that's going to make it positive, you might make fewer mistakes. So either way, but now let's get our answer here, and I'm going to draw this on a number line. So here's 4/3 somewhere on the number line, and we want all the numbers, including 4/3, this time greater or equal to. So in interval notation, the smallest answer we want is 4/3, and slide this up. We want to include that, and we want all the numbers from 4/3 to infinity not included. So you can't include infinity. Okay. Linear inequalities are pretty straightforward, other than remembering to multiply, when you multiply or divide by a negative number, to switch the sign. So I want to spend a little more time on nonlinear inequalities because these get a little bit tricky. So nonlinear just means my equation could be a fraction, for example, or any power bigger than just x to the first is nonlinear. Now, I said earlier that solving these are much like solving equations, and what would be your instincts if this was an equation? You would want to factor this. This factors into x minus 2 times x minus 8. But here's where we got to be really, really, really careful. And let's take some time with this. Let me go over here. This is a really common place to make a mistake here. Because, and I get it, it totally makes sense. Because if you were solving the equation x minus 2 times x minus 8 equals 0, so this is a different problem. But how do we get our answers? We say x minus 2 equals 0, or x minus 8 equals 0. So we get x equals 2 or x equals 8. So it totally seems logical that if you have, and I'm just going to continue going over here, that if we have x minus 2 times x minus 8 is greater than or equal to 0, that we should set this greater than or equal to 0 and this greater than or equal to 0, right? That seems to be logical. The only trouble, if I follow through with this, that gives me x is greater than or equal to 2, or x is greater than or equal to 8. Let's envision what numbers we're talking about. Numbers that are greater than or equal to 2 is from 2 this way, numbers that are greater than or equal to 8 are from 8 onward. So already there's a little bit of confusion about, okay, well, what would be our answer? Is it included between 2 and 8? Is it only numbers bigger than 8? But here's a bigger issue. What would be a number that does not seem to be part of our answer? Maybe something like 0. Well, what's the ultimate test? If I put 0 in for x, what do I get? I get 0 minus 2 is negative 2. 0 minus 8 is negative 8. Negative 2 times negative 8 is greater than or equal to 0. Greater than or equal to 0 is essentially positive, right? Or 0. So 0 is an answer. But if you solve your inequality this way, you can tell you're not going to get that answer, are you? So okay, I'm showing you something you shouldn't do. So make sure you do not want to approach the problem this way when you have multiple factors and it's an inequality. Yeah, I show that because it's a super common mistake and I want you to see why it's wrong. You're going to get the wrong answer. So what do we do instead? Once you get it in factored form and it's an inequality, we're going to use a sign chart. Sign chart is this. We're going to draw a number line and we're going to put, some books call this key numbers. Key numbers would be what would be the numbers for x that make each of these factors equal to 0, 2, and 8. And now we've divided the number line into kind of 3 regions here. So what we want to do is pick test numbers. We're going to pick test numbers. We're going to pick a number smaller than 2. So this is going to be test numbers. So maybe we try like 0, a number between 2 and 8, maybe 5, something bigger than 8, maybe 10. You don't have to use these particular numbers, right? Just has to be within the intervals here. And these are test numbers. So what we're going to do is we're going to test if we plug 0 in, and you can plug it in here. Well, 0 wouldn't be hard. In fact, we already plugged in 0 and we saw that it should be a positive number. I mean, if you plug in 0 here, you can tell that that'll be 0, that'll be 0. You're going to end up with positive 16. So you're going to get a positive answer if you use not only 0, but any number less than 2. Now, plugging in 5 and 10 might be a little more difficult to plug in here, so I usually use the factored form. And when I plug this in, all I'm really concerned about is the sign of my answer, whether I get a positive or a negative. So you don't actually have to work out the numbers. Here's what I mean by that. If I plug 5 into here, 5 minus 2 is a positive answer. 5 minus 8 is a negative answer, and a positive times a negative will give me a negative. So I put a negative there. Any number between 2 and 8, if you plug it into here, will produce a negative number. If x is equal to 10, 10 minus 2 is a positive number. 10 minus 8 is also a positive number, and a positive times a positive is a positive. So then we look at what we have. What we were looking for, again, greater than or equal to 0 means I want positive numbers or 0. What it also, the 0 part would be 2 and 8 make this inequality exactly equal to 0. So those are going to be part of our answers. And if we want positive numbers, that means we're going to want any number bigger than 8 and any number less than 2. So in interval notation, we go from left to right. So we would want the numbers from negative infinity to 2 including, or numbers from 8 including, that would be the smallest number in this interval, all the way to infinity, not including. Another thing you can do for or, a lot of times in math notation, we use U for that, which means union. For now, I don't care if you put or you put union, but when we get to calculus, oftentimes they'll use this U for union in there instead of or. All right, so let's practice more of this, and definitely a nonlinear inequality here. I'm going to start here by factoring out an x squared plus 3x minus 10. I see that this looks like it can factor more. X plus 5, x minus 2, because 5 times negative 2 multiplies to negative 10, adds to 3. And this is where you have to learn, get this instinct here. Whenever you have multiple factors lined up, multiplied together, and it's an inequality, don't start setting each of these, whatever, in this case, less than zero. Instead, you're going to go straight to the number line, the sign chart. The numbers that go on the number line are the numbers that make each of these factors equal to zero. So what makes this one equal to zero would be 2. What makes x plus 5 equal to 0 is -5. And what makes x, just x itself, equal to 0 would be 0. So then what we're going to do is pick our test numbers. So any number less than -5. Sometimes I don't even make it close. How about like -100? A number between -5 and 0, -1. Something between 0 and 2, that would be 1 would be the logical thing. And something bigger than 2, again, sometimes I don't even make it close. It's not even a close call. And then one by one, we're going to be testing. So if I plug in -100, and again, it's just the sign. That's why it don't matter. It doesn't matter what number you choose. I just worry about the sign. -100 here would make this negative. -100 plus 5 would clearly be a negative number. -100 minus 2 is negative. When you multiply 3 negatives together, 3 negative numbers, you're going to get a negative. Okay, -1. If I put that in for x, that'll stay negative. -1 plus 5, however, is going to be positive. -1 minus 2 is still negative. 2 negatives become a positive times a positive. This makes this positive. X equals 1. That means x is positive. 1 plus 5 is positive. 1 minus 2 is still negative. 2 positives times a negative is a negative. And then if x is 100, clearly if I plug them into all of these, I'm going to get all positive numbers. So it's plus. And then we just got to look at this. If it's less than 0, this means we want negative numbers and not including, right? Not including 0. But the key numbers here would make this whole thing equal to 0. So this time we don't want those. So they're going to be open circles here. And negative numbers would be these numbers and these numbers here. So in interval notation, that goes as far as -infinity to the left, -5. This time we don't want to include the 5. We want those numbers or these numbers. So now we'll use the union from 0 to 2, parentheses 0, comma 2, parentheses as well. Okay. Take a second, try to maybe pause the video, factor that as much as possible, and try to figure out the inequality. All right, so here we can start by taking out an x squared. And x squared minus 10x plus 25 factors again into x minus 5 times x minus 5, which it'd be fine if you left it like this, but you'll see for testing purposes, it might be easier to actually combine this to x minus 5 squared, greater than or equal to 0. Multiple factors here, inequality, I'm going to use the number line. What makes x minus 5 squared equal to 0 if x was 5? And what makes just x squared equal to 0 is just 0. Now, something interesting happens here. If you already tried this, you maybe saw this. I might choose -1 or -100. Maybe I use 2 here. Maybe I use 6 here. But -1 squared is positive. -1 minus 5 is negative, but if I square that negative number, that's also going to be positive. Positive times a positive is positive. And you can probably see now the fact that we're squaring whatever we plug in for this, I will always get a positive times a positive. This is going to be positive. If you plug in 6, that's going to be positive. And in this case, we want positive numbers or 0, including 0, or 0. So we would want to include the 0 and the 5. Okay, this is kind of an interesting one, but everything else is going to give us positive numbers. So we want essentially every number on the number line will work for this inequality. Now, if you weren't writing in an interval notation, you would just probably say x could be any real number. In interval notation, though, what numbers do we want? What numbers furthest to the left is negative infinity, and we want all the numbers from negative infinity to positive infinity. So this is basically the equivalent to saying all real numbers. All right. Now we've got some fractions here. And the way we'll approach it if it's a fraction is really just the same, but we just have to keep one other thing in mind, which we'll get to here. So we'll start by factoring as much as possible, top and bottom. 81 minus x squared is a difference of squares. That's 9 squared minus x squared, so it's going to factor into 9 minus x times 9 plus x. X squared plus 4x plus 4 is x plus 2 times x plus 2. And like I did on the previous one, I think I will combine this to make that x plus 2 squared. Now remember, 9 minus x is not the same as x minus 9, so we're going to leave that as 9 minus x. That's because the order of subtraction matters, but the order of addition doesn't. So if you want to, 9 plus x, you can make it x plus 9 or leave it as 9 plus x. It doesn't really matter. I guess just to show you that it'll give me the same answer, I will switch it. So we've got a bunch of factors now. This time there's some in the denominator, but it's all factored. And so the same thing, we're going to use a sign chart here to figure out our answer. And our key numbers, what makes 9 minus x 0 is 9. What makes x plus 9 equal to 0 is negative 9. And what makes x plus 2 squared is equal to 0 would just be what makes this 0, which would be negative 2. Now, I want to address the one thing we're going to have to worry about with fractions here, as you've probably been picking up on, is when it's greater than or equal to or less than or equal to, that usually means we want to include the key numbers as part of our answer. And we will, except for one of these. Think about which one of these numbers could not be possibly included in our answer. And hopefully you see that it's negative 2, right? And that's something we talked about earlier. If x was negative 2, you would have negative 2 in the denominator, and you can't divide by 0, right? Negative 2 plus 2 would make that 0. So make a note here. X cannot be equal to negative 2 in the denominator. Now, it's okay for numerators to be 0. So x could be 9. And if x was 9, this would be 0, and the whole fraction would be 0, and 0 is greater than or equal to 0 because it's equal to 0. Same thing with negative 9. So that's why we're not including the negative 2. Everything else is the same. We just had to go through that thinking about which numbers can be included and which could not be. So the next step is to pick some test numbers in each of the regions and figure out what the signs are. So maybe pause the video and take a moment to pick some test numbers and check. Okay. If I plug in negative 10, 9 minus negative 10 would actually be a positive number. Negative 10 plus 9 is a negative number. Negative 10 plus 2 is negative 8, which is negative, but if I square it, that's going to come out to be positive. So then the way we just sort it out is the numerator, a positive times a negative is a negative, but a negative divided by a positive is also a negative. Negative 7. 9 minus negative 7 is really 9 plus 7. That's positive. Negative 7 plus 9, however, is now also positive. And perhaps you notice, just like the last one, because this is squared, the denominator is guaranteed to be positive. It's never going to change, right? So then everybody's positive, and if you have a fraction where the numerator and denominator are all positive, that's going to be positive. If x is 0, 9 minus 0 is positive, that's positive, this is positive, stays positive. And if x is 10, who changes now is now 9 minus 10 is now a negative thing, right? It's a negative. 10 plus 9 is positive, and this will be positive. So we have a negative times a positive is negative over a positive. We're back to negative. Greater than or equal to 0 means I want the positives. So we would have this as part of our answer and this. So in interval notation, we would write this as -9 including to -2 not including. That means we can get really close to -2 on the left side, but just not actually to -2. And then we can go on the other side of -2, so something a little tiny bit bigger than -2, and go all the way to 9. And all of these numbers will satisfy our original inequality. A couple more here. Now, this is another dangerous place here in terms of how do we go about solving it. Again, do the same thing here. Because if I had the equation 3x plus 2 over x plus 4 equals 2, I think the best way to solve it would be to either cross multiply, something we've talked about before, or just multiply by the common denominator, which is just x plus 4. I would go x plus 4 over here, x plus 4 over there. That would cancel out. I would have 3x plus 2 equals 2 times x plus 4, and go forward and get an answer, okay? That's how you would do it if it was an equation, but inequalities are different. You absolutely cannot start this problem by multiplying by x plus 4. And think about why. The reason why we can't do that is we do not yet know what x is, what our answers are for x. And what's the one big thing we have to worry about with inequalities? Multiplying by a negative number, we would have to switch the signs. So because we don't know what x is yet, we might be multiplying by a negative number when we do that, or we might be multiplying by a positive number. Okay, so we're not allowed to multiply by x or anything with x, both sides of the equation by that. So what does that leave us with? We're going to move this 2 over. And that's going to make this less than or equal to 0. So then, and that's basically how we're going to approach all of these. You're going to want one side to equal 0, just like the ones we were doing before. So that means we're going to need to get this to be a common denominator. I'm going to add this, or subtract, I should say. So we're going to multiply the 2 top and bottom by x plus 4. And so then we have 3x plus 2 minus 2 times quantity x plus 4 all over x plus 4 less than or equal to 0. It's going to give us 3x plus 2 minus 2x minus 8 over x plus 4 less than or equal to 0. Combine some like terms. 2 minus 8 is minus 6. And once you get it to, you can think of this like, if you want to look like the last one, like a factor over a factor, right? Those are just like if it was a factor times a factor. This, we're now ready to do the number line, the sign chart. What numbers go on there? We're going to need, what makes the top 0 is 6. What makes the bottom 0 is -4. And then I always recommend, look at this here. Since it says less than or equal to, that would normally mean including the numbers, but which one is not going to be included? Even though it says less than or equal to, hopefully you can see the -4 cannot be included, but 6 can be. Okay, so note x cannot equal -4. Now, if it just said less than without an equals, then they would both be open anyhow, and you wouldn't have to worry about that. All right, next step, pick some test numbers. -7 minus 6 is negative. -7 plus 4 is also negative. A negative over a negative is positive. 0 minus 6 is negative. 0 plus 4 is positive. A negative over a positive is negative. 10 minus 6 is positive. 10 plus 4 is positive. Positive over a positive is positive. Less than or equal to 0 means negative, so there's our answers. We have parentheses -4 to 6 including. Would be my answers. Okay, one more. Maybe a good time to practice. Pause the video here. Again, remember, you can't cross multiply. You can't multiply both sides by the common denominator because it's an inequality. So the only option for these is to subtract, move it over to one side. It doesn't really matter. You could move this over here, or you can move this over here. Less than, since I'm moving it over here, that's going to leave 0 on the right side. And yeah, unfortunately, we're going to have to do a common denominator. So this one top and bottom by x plus 3. This one top and bottom by x plus 2. Same denominator, so we'll have x plus 2, x plus 3. Let's just go ahead and I'm going to have 5 times x plus 3, so that's 5x plus 15, and we're going to have -4. That negative goes to both of them. -4x, and -4 times +2 is -8. And combining some like terms, we have x, 15 minus 8 is 7, x plus 7. And if it helps, you don't have to do this, but just think of that. These are all factors, right? They're all linear factors. So we're ready to use our sign chart. The numbers that make these equal to 0, we're going to have -7. You do want to get them in order, right? That's another way you could make a mistake. -7 is the most negative, -3, and then -2. Once again, less than or equal to. So the denominator ones cannot be equal to 0, so x cannot be equal to -2 or -3. So I'm going to have open circles on those, but closed circle on the -7. Some test numbers. Okay, might have to pick a fraction here, -2.5 or 2.5, something between -3 and -2. And then I could use 0. 0 is bigger than -2. If x is -10, you can even do this. Sometimes it gets a little confusing when I put the pluses here. You could even, get some room here. If I put in -10, -10 plus 7 is a negative number, and I would be dividing that by -10 plus 2 is negative, and that's negative. I'm going to be dividing it by two negatives multiplied together. So that's really a negative over a positive, which is a negative. -5 plus 7 is a positive, but -5 plugged into both of these will give me two negatives. And two negatives make the denominator positive. Positive over a positive is plus. -2.5 plus 7 is positive. -2.5 plus 2 is still negative, but -2.5 plus 3 is positive. So it's divided by a negative times a positive. Denominator is negative. Positive over a negative makes this negative. And if x is 0, it looks like everybody's positive. Positive times positive. Less than or equal to 0. So negatives I'm looking for. right? Less than 0 means negatives. So our final answer here, negative infinity to -7, including, or -3 to -2, not including either one of those. All right, that's it. We'll practice some more of this in class.